Okay, here's warm up 9.2.1. I'm going to want a scientific calculator for this warm up. So this first problem, we're solving for x here. We can't use the Pythagorean theorem because we've only got one of the three sides, so we don't have enough information for that. It's not a special right triangle either. It's not a 30, 60, 90, or a 45, 45, 90. So what we're going to want to do is use SOHCAHTOA. All right, so here, I'll write that up here. I made the S, the C, and the T bigger for sine, cosine, and tangent. Okay, so we want to place ourselves at one of the acute angles. You want to be at the one that's marked, so I want to be at the 35-degree angle. So I'm thinking of myself down here. There I am, okay? And then I'm thinking about what parts of the triangle am I dealing with. The hypotenuse is unmarked, so I'm not dealing with that, but I'm dealing with the opposite leg and the adjacent leg. So then I'm thinking about SOHCAHTOA, and I want to choose the part that uses opposite and adjacent, and that would be tangent here. Okay, so tangent, I want to say where I am. I'm at the 35-degree angle. The tangent of 35 degrees then is going to be opposite over adjacent, so 12 over x. Okay. Now, we need to solve this for x. You could multiply both sides by x and then divide both sides by tangent of 35 degrees to isolate the x, and that's totally fine. But when I have the variable on bottom like that, I like to just switch these. I call this the incredible switch. There's a maneuver I invented. It goes whoosh, like that. So the x is going to end up out here. And then I've got 12 over the tangent of 35 degrees. Okay. And then that's, I need to type that into the calculator. So let's see. In these types of calculators, you can just type it in exactly as it is. Make sure you're in degree mode. So if you get a different answer than me here, check your mode, make sure you're in degree mode. See, I can see I'm in degrees, not in radians. So this is what I got. Some calculators, you might need to find tangent of 35 first and then do 12 divided by that. Going to the nearest hundredth, so about 17.14. Okay. All right, same kind of deal on the next problem. I mean, you could use Pythagorean theorem to find this side. It would be 13, but that's not telling me the measure of this angle, where the theta is. Okay, so we want to put ourselves at an acute angle that's marked, so not this one, but I want to be up here. And this time I've got opposite and adjacent again. So I'm going to use tangent again. I want to say where I am. I'm at the angle marked with theta. This is the Greek letter theta, right? And then opposite over adjacent would be 5 over 12 from there. Okay. Now this time I need to isolate the theta somehow, and I can do that by switching the position of those two things. Now you can't just switch them for no reason, but that's where the inverse of tangent comes in handy. So the inverse tangent, which I'm going to write like that, I've got a little negative first thing. That means the inverse of tangent. That's going to switch the position of these two things. So 5/12 is going to go there, and then the theta is isolated. And that's good news because now I can put this into my calculator, and it can tell me, you know, when I've got 5:12 ratio of those two sides, you can tell me what this angle is going to be. Okay, so if you know where the tangent key is, it's in the same place, except it's a little hard to see here probably, but written in blue letters above tangent is tangent to the negative first, which is actually inverse tangent. So I'm going to hit the second button up here, then tangent, and you can see now it shows up on the screen like that. And then I'll type in 5/12. Some calculators you might have to find 5/12 first and then take the inverse tangent of that. Okay, and going to the nearest hundredth, that's going to be about 22.62. And I also want to show that this is the measure of an angle, so this is in degrees. It's important to put that because it's not radian measure. Okay? All right. Next problem. We're going to find the cosecant of theta if the tangent of theta is root 11 over 5. So we have to know the definition of both tangent and cosecant. So cosecant is going to be the hypotenuse over the opposite, where tangent is going to be opposite over adjacent. Okay, so I actually already know the opposite. This would be the opposite, right? And then this would be the adjacent down there. So, hey, the opposite, that's going to be part of this. So cosecant of theta then is going to equal something over the opposite. The opposite here was root 11. Okay. Now I still need to figure out what that something is. That something is going to be the hypotenuse of this triangle. But what I can do is just set up a triangle, a right triangle I want to use, okay? And I want to put theta at one of the acute angles. I'm going to put it at this bottom left one, okay? And then I'm going to use what I know about this. This says that the opposite is root 11. So the opposite from here would be root 11, okay? And the adjacent would be 5. So since both these are positive, I'd be going right and up. So that makes sense there. But it doesn't really matter because the hypotenuse will always come out positive even if one or both of these values were negative. Because I want to find the hypotenuse here. I'm going to put a c there in honor of the Pythagorean theorem. So now I'm going to use the Pythagorean theorem here to find c, because in any right triangle, a squared plus b squared is going to equal c squared. So a and b would be the 5 and the root 11. Okay, 5 squared is 25. Root 11 times itself is going to be 11. The square and the square root undo each other. Okay, and then this is 36 equals c squared. Well, I take the square root of both sides, and then the hypotenuse is always positive, so this is 6 then. And then there's the other piece I need, right? So this was going to be hypotenuse over opposite. Now I know the hypotenuse is 6. And the only thing left to do is put this in simple radical form. I've got that radical in the denominator. So I want to find a twin for the 11. There isn't one right now, so let's clone one like that. And we just have to do the same thing to the top. And then so when I multiply this through, I get 6 root 11 over, I have twin 11s down there, so 6 root 11 over 11. And there's the value of cosecant. All right, and that's the end of the warm-up, and I'll see you next time.